Okay, well, welcome everyone to this meeting of the virtual IMS user group. Thank you for joining us, and I'm sure we'll have more people joining us shortly. I'm Trevor Eddles. I'm CEO of iTechEd Limited. We're a mainframe consultancy, analysis and technical authoring organisation, and we're responsible for the content on the virtual IMS website and also writing the newsletters. If you haven't found it, the website can be found at iteched.com/virtual IMS. And just a note, we also look after the virtual CICS user group too. So let's run through the agenda for this meeting. As usual, most of the meeting will be taken up with a presentation. And today our guest presenter is, excuse me, our guest presenter is James Martin, Senior Solutions Advisor at Rocket Software. And his talk is Performance and IMS, and he's calling it part 2 because part 1 was actually at the GSE conference in November. A copy of the slides from this presentation will be on our website later today, and if you've missed any of our previous meetings, you can download copies of those presentations as well from the website. And you can also listen again to the whole session. You'll find links on our resources page. Following James's presentation and any questions you have for him, we'll move on to the latest IMS news and IMS related articles. Feedback requests is there to remind me to ask you for your feedback about this virtual meeting. And then I'll give you the dates and times for the next couple of virtual meetings. So that's the plan for this meeting, and I'm anticipating that it'll last just under an hour. Anyway, as I just said, today's presentation is from James Martin. James is a Senior Solutions Advisor for Rocket Software and an IBM Preferred Development Business Partner. He's been working with the IBM IMS performance tools for 13 years, and his work history includes 3 years with IBM, working as a client technical professional in the IMS tools space, and 10 years at Fundy Software, working in a technical sales, support, and software testing role. As an IBM CTP for North America, he travelled to various customer locations, supporting and promoting IBM IMS tools. He's spoken at a wide variety of conferences and user group. He's an ASTQB certified tester and has held various testing roles, including a 2-year stint as the test lead for IMS Problem Investigator product. And in his current role as a Senior Solutions Advisor, James travels to various conferences and customers in North America, South America, Europe, Asia, Australia for speaking engagements. Although I guess this year there hasn't been that much travelling. And James is also one of the IMS project managers for the Share Technology Conference. So, James, I'd like to thank you very much for being with us today. And what I'm going to do now is stop sharing and pass control of the meeting over to you. So let me do that now. Should have a message on screen. And we can see your slides. Yep.
Thank you, Trevor. As Trevor said, you know, the traveling this year has been kind of unique. Been traveling virtually more than we have been traveling physically these days. But again, I always like to talk to customers and hear their feedback and help them with their performance issues and things like that. So anybody can ask questions at any time throughout the presentation. If you want to wait until the end for the question and answer session, that's fine. I'll try to answer any questions that you guys have. Today, I'm going to be talking about performance in IMS. And as Trevor said, this is part 2 of a 2-part presentation. In the first part of the presentation, I discussed the overview of the products that a lot of tools, especially from the IBM side, that customers use when they're monitoring, doing performance tuning in IMS. Why do we performance tune in IMS? Well, because workloads are ever growing, as can be seen by the second slide here. IMS was actually created in 1968, as all of you know, to manage the large bill of materials that was needed for the Apollo space program. It's kind of stuck around since then. People have uptaken it for database solutions, and you can see over there on the right that today IMS is processing 265 billion transactions a day, 3 million transactions per second. And over the past 50 plus years, the IMS team has really been delivering features that make IMS a day-to-day part of of your enterprise and of our lives. I think everybody probably uses IMS on a daily basis, whether they realize it or not. So when we're talking about performance in IMS, and this is the agenda for our presentation today, we typically talk about key performance metrics and the tooling that's available out there for us to measure these key performance metrics. And today I'm going to focus mostly on IMS tools that are provided by IBM. These are the tools that I use in my day-to-day work, and most of you probably use in your day-to-day work in your enterprise system. I'm going to talk briefly about a resource measurement facility and some of the ways that we can look at performance on an overall Z basis using a tool like Resource Measurement Facility, or RMF, as most of you know it. I'm also going to talk about the way we can use IMS Performance Analyzer to look at these various performance metrics in IMS specific. I will also touch on a couple of other performance tools from IBM, the IMS Problem Investigator and IMS Connect Extensions for those of you using IMS Connect in your enterprises. So when we talk about these performance analysis tools, these are some of the ones that are the most commonly used by customers out there in the world today. Not everybody has all of these, and I'm not going to talk about all of these, but I wanted to make sure you guys had a pretty comprehensive list of all of the tools out there available to help you from a performance reporting, from a performance tuning standpoint. All of these things can be very beneficial to you in your day-to-day operations. The tools we're going to focus on mostly today are RMF and IMS Performance Analyzer, but as you can see by the asterisks in below, we are also going to talk briefly about the IMS Problem Investigator and IMS Connect Extensions. Connect Extensions will be talking primarily about a new feature in the latest release of Connect Extensions called the IMS Connect Extensions feed. And when we get to that part of the presentations, I'll talk a little bit more about that. A couple of the other ones that I'd like to really point out here, one is OmegaMon XE for IMS. That's our online monitoring offering from IBM. I think every customer should have an online monitoring capability, mostly because those online monitoring tools, I call those I have pain now tools, which means they allow me to identify performance issues very quickly as they're happening. And then after I identify those performance issues, I can use tools like RMF, IMS PA, PI, and Connect Extensions to make sure I don't have pain later. So those are the tools that I refer to as, let me fix my pain. I fix my pain so I don't have it later on. And that's how I typically approach a performance issue or a performance problem that I'm working on. And in those performance tools analysis, what do we always need? As customers, we always need data, right? I mean, the more data that we can get about a performance issue when we're trying to tune, when we're trying to fix particular performance issues, data is something that we have to have. And a lot of times we look at different types of instrumentation data to solve different types of problems. This is a list of some of the instrumentation data that I'll be talking about today. SMF records is something that we can always look at to gain more insight, especially from an overall Z perspective. SMF records are something that give us a lot of detailed information about things like long lock situations in IMS. SMF 88 records can show us information if we're in a shared queue environment. Also SMF 98 with the new HFTS function in ZOS, you can see detailed information about areas of aspects of ZOS like coupling facility information, serialization information, DASD usage information. All of that type of information is very valuable when we're doing a performance tuning or a performance problem issue in IMS, because a lot of times IMS is just really not the problem. There could be a problem with Z. There could be a problem with another subsystem that we're using, such as DB2 or CICS or anything like that. Again, seeing the performance of the overall Z system helps us to determine, well, is our problem really IMS or is it not? Then if we do determine that it's an IMS issue, we have a lot of other instrumentation data that allows us to delve into those performance issues within IMS. Primarily, we use IMS log records. IMS log was built for recovery, but there's a lot of performance information inside of those log records that allow us to really get in and find the heart of the issue. When I talk about IMS log records, I'm also lumping in there, if we are an IMS Connect customer, there is tooling out there that allows us to collect instrumentation data records around IMS Connect. I'm going to talk about IMS Connect Extensions, which builds journals, which are very similar to the IMS log, that allows us to get instrumentation data, get performance data from an IMS Connect perspective as well. The IMS DVDC monitor data is very, very useful, but very, very voluminous. A lot of times we don't see customers using that monitor data on a daily basis, but they will use that monitor data when it comes down to pinpointing a very specific problem and looking very deep into that problem. So monitor data is out there as well. Dumps is something that, as performance people, we've been looking at for years. But I feel that with the increase in the popularity and the increase in the function in a lot of the performance tooling, we don't spend as much time looking at dumps as we used to in the past. Okay, we can now look at that performance information in the tooling that we have, and it allows us not to have to go to the dumps, not to have to trace various log records and associate them with other transactions and try to put that all together like we used to in the past. There's a lot of external traces that are available to us as well. As far when we talk about IMS, there's all kinds of slash traces, DLI traces, all kinds of traces that we can turn on or turn off, and we can implement that instrumentation into our performance analysis as well. And there's GTF traces. I mean, having data from both a good and a bad problem period is very useful to help you see what's different. And whenever I'm doing a performance analysis with a tool like Problem Investigator, for instance, I always like to see a before or a time when that transaction is performing well, and a snapshot of when that transaction is performing poorly, because it really helps you pinpoint points in the instrumentation data where you're seeing time slip away. And that's when we talk about performance, what we're really talking about, isn't it? It's where the time goes and where we see that time being used where we don't expect it to be being used. So the first thing I'm going to delve into, as I said, part one, I did overviews of all of these products and talked a lot about what the products are used for, how they're used, and things like that. Today, we're going to focus on the types of reports that we can get out of this particular tooling that allows us to see the aspects that I'm talking about from a performance standpoint. So the first thing we're going to talk about is RMF analysis. So when we're looking at the overall Z performance using a tool like RMF, we need to be able to look at data from RMF and analyze various different reports to see certain types of activity. Things like CPU usage, sub-channel activity, coupling facility activity, if we're using coupling facilities, and serialization delays can all impact the way our IMS systems are performing. Okay, those are all things that we'd like to take a look at. So the first thing we're going to look at here is just the RMF Monitor 3 workload activity report. You can see here that I actually get very detailed information around CPU usage, CPU and SRV times, execution details, all that type of information is provided by RMF. And don't get me wrong, I'm not an RMF expert by any means. So there may be a lot of other information in some of these reports that I don't personally point out that you guys know about. But you can also see that I get very, very detailed information about storage, the average storage usage and the total storage usage, and page in and page out rates. And in this particular case, and in the systems that we see to do today, paging is something that we really don't see very often. So if we see numbers come up in these page in rates, we know we have a performance issue somewhere almost immediately these days. Several years ago, we might be used to seeing numbers in here, but not anymore. And the transaction rate per second is right here. Again, if we were to see a very high number here, and this is not a small number that we're identifying here, we would want to understand why we're seeing delays in those transaction rates. And as I talk about RMF and looking at the overall Z performance, while we're not looking directly into IMS, we can see that IMS is a piece of this entire enterprise, and maybe this would give us a clue or tell us that we really need to go in and look at those transaction rates in IMS to see what part of the overall delay they are taking part in. Again, it's all about pinpointing issues, and it's all about finding those issues within the subsystems in the overall Z picture. Oh, another important piece that I've already pointed out is the CPU service time. Why is that important? Well, we're all billed the same way pretty much, right? We're billed based upon our CPU usage. So again, very good information from RMF around service time and CPU usage. Now, does this break it out into detail over IMS is using this part, DB2 is using this part? No, it doesn't do that. But it does allow us to see, on average, how much CPU we're using, right? And if we see that number fluctuate up or down, we can identify, oh, well, we may be having an issue here because on average we usually do this amount of CPU, and this month we did this month. Why did that increase? Also, I talked briefly about RMF Monitor 3 serialization delay reports. Okay, this report can help me analyze serialization-related performance issues. Okay? And you can see it provides contention information on system and address space. Again, looking at the overall picture. Okay, you can see that I have various different types of contention listed on this report. I also have GRS information in here, and it shows me the delays and the total contention counts so that I can start to gain some insight into into any serialization delays that I might be having. Okay, and these are post-processor reports in RMF, just to make that these are not online or live reports that we're looking at here as well. Just to expand on it a little bit, you can see that I can also see CML and local lock information. You can see I can get detailed information about lock total contention times. And locking is something that we experience in IMS all the time, and not only IMS, but overall in Z. And locking contention can be something that causes us very serious delays. So if we see high numbers in these locked total contention times and average times and things like that, which we're not really seeing in this report, but you can see that these can definitely be serialization issues within Z. How are our subsystems serialized around things like sync points and all those types of things? Just really good information for us to understand. Here's a coupling facility usage summary report from RMS as well. As I said, if we're using coupling facilities, it's important for us to understand how that usage is occurring. Are we seeing delays in the usage of those coupling facilities as well? We can see the structures over there on the right and the percentages of the allocations and how much of the storage that we're using in those particular coupling facilities. Again, we typically don't like to see large numbers of CF storage being used. Something that we could definitely identify. You can see there's a couple of jumps here that from the 0.2, here's a one that's a 4.3. I might want to look into that particular aspect of this report, and maybe that's normal and maybe it's not. But again, just types of things that we need to look at when we're talking about overall performance in Z. And we can also see information about coupling facility structure activity here. You can see there's detailed information on each particular structure, so it breaks it down by each particular CF structure and shows you the activity. You can see I'm not showing any delays here, percentage of requests or average times or anything like that. So this particular report would not be telling me much of anything, but if that information was there, I would be able to see it. Change, delayed requests, sync and async requests, all those types of things I can see in these types of reports from RMS. And here's the RMS Monitor 3 coupling facility subchannel activity, another report that's very good to give us information. The number of types and links from each subsystem that we're using, and the PTH busy number. Those are really key indicators when we're looking at performance, right? Because if we see the number of links going up or down, that can cause us some concern, and the amount of busy time that we see definitely could cause us some concern, because if those facilities, sub-channel facilities are busy, that means there's delays in processing, right? So we just some insight and some aspects, and it also shows us, the busy also shows us the number of coupling facility requests that were rejected. And that could be a key indicator as well to why we're seeing a degradation in Z performance as well. The next thing we're going to talk is how we can use IMS Performance Analyzer to delve into the subsystem of IMS and gain a performance viewpoint and analyze any performance issues that we might have in IMS. And there's lots of aspects of IMS Performance Analyzer. As Trevor could probably tell you, I could probably do a 2-day presentation on just Performance Analyzer. So for time's sake, I'm trying to focus on aspects of Performance Analyzer that can help you pinpoint issues. Of course, I'm not going to give you an overall product review and show you all the aspects, but I think if there's anything performance-wise around IMS that you want to investigate, Performance Analyzer is a tool that you really, really need to be looking at. I'm going to look at the log information report, and I'll kind of go into detail on all these reports as we go through. We're going to look at transit or transaction performance analysis using Performance Analyzer, maintaining our distributions and service levels, because as customers, we're all bound by distributions and service level agreements with our customers that we have to meet, right? So that's something from a performance standpoint that we definitely have to understand. PA is really good when we talk being able to analyze the message queue pools using Performance Analyzer. And those message queue pools could be shared queue or non-shared queue. So we'll take a quick look at both of those aspects. And one thing that we sometimes rarely think about when we talk about performance in IMS is our batch workloads, right? Our batch workloads, are they taking checkpoints? Are they taking enough checkpoints? Are we taking too many checkpoints? Because checkpointing in our batch workloads can cause delays in our overall IMS performance, something that we really, really should pay more attention to in some cases. And sometimes we do, and sometimes we don't, okay? The other aspect I'm going to touch on today is sync point and the way it can affect response times in IMS. A lot of times when we talk about performance in IMS, we don't really think about, well, sync point processing, especially if it's a coordinated sync point with other subsystems, can cause large delays in IMS. And if we're using things like DAS demirroring and some other aspects in IMS, then we can also see delays there, and sync point processing times can show us that type of information. The first report I'm going to talk about is the log info report. And the log info report is executed anytime you run any report in IMS Performance Analyzer, or if you run batch reporting in the IMS Problem Investigator, you also get this report. And I always like to talk about this report as insight into the logging of the instrumentation data that we're doing in IMS. Because a lot of times we can just take a look at the type of logging that we're doing, and we can determine that there may be a problem. Depending upon what type of logging it is, what code it is, we can see performance issues sometimes without even having to run any report. So it's always good to have insight into what we're logging, how much we're logging, and all of those types of things. So I always like to talk about the log info report that you can get anytime you run a report in Performance Analyzer.
James, I've got a question for you. This is from Wanda Yang. How many checkpoints in IMS batch will be considered too much or too little?
Well, you know, typically speaking, when we talk about checkpointing in batch workloads, it depends on how much work it's doing, right? So if we're checkpointing frequently, okay, and when I say frequently, maybe every 5 seconds, 4 seconds, or something like that. It just depends on how large your batch workload is. So if we're seeing a checkpoint every half a second, I would say personally, to me, that's excessive checkpoint. Okay, but it basically just goes from installation to installation. And you kind of determine how many checkpoints you want to take, you need to take, and all of those things. Because if we're not checkpointing enough, then we can run into issues with recovery, right? Because if we're not checkpointing and IMS goes down, you know, we're only going to recover to the last checkpoint. So, you know, you could run into some serious issues, maybe even some database corruption issues and things like that. So it's kind of a personal preference thing, but I would think personally, I would want to see minimum of a checkpoint every 4 to 5 seconds, somewhere in that neighborhood. But if we're checkpointing more frequently than that, it's okay. I just would say that checkpointing every half a second or less than that is probably too much.
Okay, thank you.
So when we talk about analyzing full function transaction response time, or even fast path transaction response time in IMS, this is really what we're talking about. We're talking about the 5 parts of the transaction flow into IMS, and that's the input time, and then the input queue time, which is the amount of time that the request spends in the queue waiting for the 31 record, right? The get unique record. That means we have now scheduled that particular transaction for work. And then we look at the processing time. The MPP has been scheduled, or the message processing region is scheduled, and now we process or we go and do our work. Now, a lot of people would say processing time is not something I have to be really concerned about because IMS is so fast and everything processes so quickly. Well, there are a lot of aspects around processing time where we can see delays. We could see program switching. We could see all types of different aspects around processing time. So again, I think processing time is very important to look at when we're talking about performance in IMS. And then at the program terminate, we sync point, whether it's coordinated or not. And then we have the output queue time, which is the amount of time the message sent spends in the output queue before that message is sent back to the originator or the sender, right? So when we talk about performance in IMS, we have several different aspects to look at that we can break out: input queue, processing, and output queue. And then if we look at the entire picture, the input time to the output time, we get our IMS total time, okay? So that way we can actually look at aspects of, well, how much total time are we taking versus how much time are we taking in each aspect, right? Because the overall the IMS total time can also include work in other subsystems like DB2 and MQ and things like that as well. So we have to remember, if we're looking specifically at IMS performance, a lot of times we have to break it down by input queue, processing, and output queue time, so we know how much time we're actually spending in IMS as opposed to how much time we're spending overall, right, in IMS total time. So a lot of times when I'm looking at aspects like this and I see a IMS total time that's pretty high, but then I delve into the actual individual aspects and see input, processing, and output queue time in IMS is good, I immediately go to, well, were there other subsystems involved, okay, because the total time can be affected by that, whereas the other three aspects are not. Those are strictly IMS aspects. So when we're looking at PA, or using PA and looking at transaction response times, this is a transit time analysis by transaction code, which tells me that I'm going to see by transaction code information that will allow me to determine if I'm performing as I should be, okay? Here I'm looking by PSP and I get response counts, minimum tran times, input queue times, switch queue times. If I'm doing program switching, I'll have numbers in the switch queue, okay? So it says that I'm actually doing program switching. This particular report, I'm not doing any, but a lot of times customers are doing heavy program switching, and this report can help you identify how much switching you're actually doing. There are other reports in PA that would allow you to actually delve into the switch time and see how many switches and where the switches are going to and all of that, but we're not going to cover that today due to time constraints. You can also see that I have average transit time up there at the top, which will include the input queue, the program execution time, and the output queue time, and it's even broken down by queue types. You can see CQS, with shared queues, local queue, all that type of information. And then on the right, I'll have my total time, or that's my IMS total time over on the right over there. Again, being able to identify problems that are in IMS versus problems that could be somewhere else as well. And this report in particular was just going to help me understand if I need to do a deeper dive analysis to understand what the problem is and find where the problem is so that I can solve the problem and not have it again. You can also see on the far right-hand side of this particular report, I have average CPU times over there, and they're all zeros in this case, so we must be processing really good. Now, this is an example of a fixed report in IMS Performance Analyzer, okay? This report is a report that's been in there for years and years and years. I showed this example, but what we're encouraging customers to think about is this particular report can be moved over into our forms-based reporting, which is customized reporting that will allow me to break it down into much more detail. And these timings are all in milliseconds. I could actually break those timings in forms-based reporting into seconds as well so that I don't have to do those manual calculations. But again, any report that is in the fixed report can be duplicated in forms-based reporting, and there may already be a sample form in Performance Analyzer that allows you to run this same report and customize it to your needs. And I talked a little bit about distributions and service levels. We're all bound by service levels in this business. We have to meet minimum amount of service for our customers. So it's very, very important that we understand if we are doing that. And we can actually want to keep a history of how often we are meeting those SLAs versus how often we're not meeting those SLAs. And in this particular report is the response time distribution. Now, this is an actual forms-based report that I built and ran against a test system. And in my use case, the user-defined thresholds were less than a millisecond, 1 second to half a second, or greater than half a second, okay? And I actually wanted to report as either a percentage of all the transactions or as a count. And you can see that I have averages, minimum total times, and all of those aspects. And if I was to look at these particular things and understand what my SLAs were, and in this case, you can see that I have several, 95% of the transactions, the service level was 95% of the transactions had to have a response time less than half a second. And if I look at this particular report, I could see immediately by looking at the over half a second column here that 95%, that pay, stock, transfer, and withdrawal do meet the required service level, okay? With less than half a second, you can see I have 100% in pay, 95, 96, 96. But balance, log on, and order, I can immediately look at this under half a second total time and see that only 93%, 93%, and 94% met those service level agreements. So I would now know I needed to go and look at the tran codes, balance, log on, and order, and figure out why we were not meeting the service level agreements around those tran codes. Again, quick insight to performance issues that I'm having, and service level agreements are very important. So we would definitely need to do a further investigation from this report on those three tran codes. To pinpoint, you can see there's multiple counts of them as well. So I would need to pinpoint which ones were actually making me not reach my service level agreements. And I could build a list report. This is a summaries report. I could build a list report for those three tran codes that listed out each individual execution and gave me the same numbers in this particular report. When we talk about IMS message queues in IMS, it's really important for us to understand how many calls or message queue calls are being satisfied in our buffer pool. Right? So if we're doing a large amount of calls, we definitely want to see a large amount of those locate calls being satisfied in the pool. Because if we're doing that, then we're not doing paging, we're not doing IOs and all of that. Again, performance, right? Using less CPU, because we have all of those, that information in the pools, and we have to understand that we want to keep that number high. And this is just a really quick report to make us understand how much IO we're doing versus how many locates we're finding in the pool. And this can be done for message queue pool statistics. It can be done for the various buffer pool statistics as well using IMS Performance Analyzer. This is just an example, but again, if we're locating 93 to 95% of calls in the pool, I think that's a pretty good number. if we start to see that drop to 90 or below, 90% or below, that means we're doing a lot of I/O, and that could cost us CPU, flat out cost us money, right? I mean, because that's what I/O is, CPU. If we wanted to break it down further, if we were in a shared queue environment, it's not as easy as just going and running the resource usage and availability reports that allow us to see buffer pool and message queue statistics. We want to see a better breakdown of how those queues are being used, because in a shared queue environment, we not only have local queues, but we also have local first queues where we actually bypass shared queues altogether. And we also have global queues where we're sharing transactions across multiple systems in some cases. So understanding how many transactions and how much processing time is being used in each one of those queue types can be very useful to us to understand how basically our shared queues environment is working. And you can see here one of the key things that I look at in this report to start to understand things is, first of all, what queue type is it? Is it global queue? Is this the local queue? Is it the local first queue? And you can see in this particular case, the majority of my transactions were bypassing shared queues altogether. So I might look at this particular report immediately and say, well, I'm not really using my shared queues environment to full capacity unless those particular transactions that are running local first, that's the way they have to be run. Okay, but if I want them to be in the global or the local queues, I would really need to understand how my scheduling is working to understand why I'm not taking full advantage of my shared queues environment. Also, this gives me information about input queue processing time, and these are averages now, so this is a performance-based summary report, and averages are great, but it might be useful if I see some high average processing times and things like that here too, to go ahead and break those IMSs down into list reports. And I also see information about CPU and percentages over here on the right. The other thing that we always like to understand in a shared queues environment is our fall schedule and WIPI analysis report, which you can see here on the bottom. Again, another forms-based report. But when we're looking at fall scheduling in IMS, that's something that's a very key metric from a performance standpoint, right? Because if we're fall scheduling and those schedules are not getting quickly rescheduled or something like that, well, we're spending money to not do any work, because when we schedule a transaction in IMS, we're being billed for that schedule. Whether it actually runs any work or not, scheduling costs money in IMS. So it's really important to understand when we're looking at scheduling in this particular report, anytime we see that equals 0 column, that is a false schedule. So you can see total, we had over 1,400 false schedules in this particular report, right? So that's something that we really, really need to pay attention to in a shared queues environment, is how many false scheduling that we're getting. You can see I have information about DLI calls in here as well, CPU time, and WIPI sub Q6, which is the wait for input or elapsed time. WIPI program actually waits for the next input. And this quick number is the amount of actual quick reschedules that were done in that scheduling period as well. But again, understanding how our queues are reacting to our workload, very important metric around performance. Now, when we talk about program scheduling as well, something that we don't look at a lot of times, program scheduling optimization can really help us performance-wise, because a lot of times customers will have hundreds of message regions, some of them rarely used, and they may want to do something like undertake a region consolidation exercise, right? Consolidate our regions. If we've got regions out there that are running and costing us money and we're not using them, we either need to readjust our scheduling algorithms so that we do take advantage of them, or we want to consolidate that workload into other regions that we are using more heavily, right? So we can build a forms-based report for region utility that will help us understand how we're utilizing those regions, okay? How is our program scheduling affecting the regions that we do have, and are we using them enough? And after we build that form, we can run the report that allows us to actually look at job names, PST types, and region types that we're actually using. These are all message processing regions. And we can see our tran counts, our scheduling times associated with things. Total scheduling times, processing times, average processing, and total CPU being used in each region. And we could identify very quickly that while these top regions are being very heavily utilized, these bottom regions down here are not being utilized at all, right? So in this particular instance, we might look at certain aspects of this and say to ourselves, well, should we consolidate the work that's being done in these other regions into the regions that are being heavily used and clean these other regions up? We don't need them anymore? Or should we break that workload out of those heavily utilized regions and actually utilize those other regions since we have them there anyway? Again, that can go either way, and that's a installation by installation determination. But again, something that you can do using IMS Performance Analyzer to understand how well your scheduling algorithm is working. Now, I talked a little bit about BMP checkpoint frequencies. We had a question about that just a minute ago, and in the new BMP checkpoint report that was just released in the latest release of Performance Analyzer, which is at 4.5 now, we can actually run a BMP checkpoint report, and we can give it average checkpoint frequency limitations, or what our installation thinks is a good number. We can look at minimum amount of checkpoints and how frequent they're being taken, and maximum amounts of checkpoints as well. So exception criteria around our checkpointing activity. Reports only BMP jobs with database activity, so I can tick this. I only want to see BMP jobs that are updating databases, or I can untick it and look at all of my BMP workload, right? And like I said, the average checkpoint frequency can be used to get a desired checkpoint rate for our BMP workload. And you can see here that if the rate is less than the minimum, you'll see a low reported in the report. If the rate is higher than the maximum, you're going to see high in the report. So that is an immediate eye catcher in the report. Here's the link to the Knowledge Center where you can get more information about this. But that's an immediate eye catcher in the report that allows me to determine, oh, wait, high. Okay, that means we're over our maximum checkpoint frequency. And if I look at the report, and this was done with, test system data, obviously, but you can see I have a count. I also have the durations or the frequency that I'm taking checkpoints. And in this particular instance, the count was 7. The minimum was a 3.12, so that's going to be low, right? Again, a 0.10 is low as well. So I didn't have enough workload on this system, obviously, to get that checkpointing too high for the one. So yeah, you just have to understand that we're looking at this particular report just to indicate the frequency of checkpointing that we're doing in our BMP workload. Now, sync point processing is something that I also said is very important to understand, right? So when we're looking at sync point times, right, phase 1, phase 2, if we're talking about fast path, we can see phase 2 fast path and O-thread times as well, and look across our tran codes to see how long they're taking to checkpoint. And you can see here that if I look across this particular report, I see pretty low numbers. I think that's microseconds, might even be less than that, that I'm seeing checkpoint frequencies, but I do have 3 on this report, especially this bank 1 tran code that's taken a long, long time to checkpoint. I mean, that's almost almost a half a millisecond, or almost a millisecond for checkpoint or sync point. And that's really not something that you see very often, right? These higher numbers in sync point times could indicate very quickly that something else is wrong, whether it be a coordinated sync point, whatever the case may be. A report like this could help me quickly realize, okay, well, I need to go and use another tool or do a deeper dive investigation to see why is my sync point taking so long. Again, the longer we sync point, the longer our IMS total time is going to be, overall performance degradation. Now, quickly to wrap up here, I got about 5 more slides. A quick look at IMS PA. Once we've run a wealth of reports from PA, once we've identified issues in transaction performance, we can use a tool like PI to actually do a deep dive analysis into the problem using that same group of instrumentation data around IMS. I can create some reports, some CSV files for off-host analysis, and log extracts as well. But what PI really stands strong is its ability to actually use the ISPF dialog to do an interactive analysis to allow us to see where in a transaction flow our time is going. Okay? Here's an example of some CA20 records. IMS Performance Analyzer builds these particular records because IMS, unlike some of the other systems of record, do not have an overall accounting record that allow us to see the total performance of a transaction in one instrumentation record. So using PA, I can actually build records around IMS, in this case, IMS Connect, using IMS Connect Extensions that do show me all of the transit or transaction performance information about a transaction in one record, similar to the CMF 110 record or the SMF 101 in DB2 that show us or account all of the performance around a quote-unquote transaction. But where PI really stands strong is its ability to track a transaction from start to finish. In this particular case, we're talking about an open database transaction which uses IMS Connect, uses IMS. In this case, I have some OmegaMon XE for IMS ATF data. Some IMS monitor data is included in here as well. But the key thing for IMS Problem Investigator is being able to see where the time went in a particular transaction, right, by transaction. So, of course, we start with Connect receives the open database request, and this kind of flows through the transaction. Not going to spend a ton of time on it. The Connect calls the security exit. That's this DRDA 05B. This is an open database transaction. They're exchanging the server attributes, saying this is the way I want to play. And IMS is saying, well, this is the way I'll let you play. Then Connect requests, forward requests to ODBM. That's where the security exit is called. The security is checked. And we see the access RDB or the relational database. Again, open database. We don't talk relational database in IMS, but we then again allocate the PSB here, this program AUT PSB11. The routing exit's called. The IMS processes the open database request. You can see here, here's the 4EZ002, the BMP scheduling start 06 and the 40EZ02. That's the ATF record and the monitor record. And here's our 08 application start. So we're actually starting our processing in IMS. The response returns via ODBM to IMS Connect. You can see the start of unit of recovery, scheduling end, message received from ODBM. So again, we're flowing through this transaction. IMS Connect receives the next request. Okay, so we write the socket, the RDB reply message, and here's our open query. and you can see here our open query for a relational query call or SQL call is being translated into DLI, because that's what IMS speaks, right? So we translate the DLI, we send a segment search argument. It wants to retrieve the following data, and then the DRDA conversation continues until the PSB is deallocated and the socket closes. But again, tracking a transaction from start to finish is where PI really shines. And the reason it does shine is because it allows us, using relative or elapsed times, to pinpoint points in the transaction where time is going away that we might need to do further investigation to figure out. So you can see this is relative time, and I have a jump from 0.8 milliseconds to over a second. So there could be an issue there, and that's between the write socket and the read socket. So something happened in between that write socket and the read socket that might require further investigation. Well, why did we have a 0.2 millisecond? What took 2 milliseconds or 3 milliseconds in between a write socket and a read socket? I would think that was really fast. So what happened in there, and where do I go to pinpoint that information? Again, it's all about finding out where your problems are and investigating from there. And as I said, this particular example shows IMS Connect Extensions journals, and that this is color-coded for the type of instrumentation data that you're looking at, okay? And if we needed to, we could also include some other instrumentation data around it that's not shown here, around other subsystems that we're using, and MBS or CQS instrumentation data as well. Now, IMS Connect Extensions analysis. Connect Extensions has always been known for its journaling capabilities, similar to the IMS log, but we always use other tooling like PA and PI to gain insight into performance in IMS Connect, right? Well, with the implementation of IMS Connect Extensions version 3.1, we introduced a feature called the IMS Connect Extensions feed, which actually allows us to feed near real-time instrumentation or performance data about IMS Connect to off-host platforms like Splunk or ELK or things like that. And we can do that by either using SMF data or by using JSON lines format, streaming over TCP/IP with secured socket connections, of course, and put that instrumentation data into Splunk or ELK, okay? So that's the key thing to remember here, is we're talking about forwarding or feeding instrumentation data about Connect into off-host platforms. And here's a developer works link down here where you could get more information about this. But putting that information into Splunk allows us to look at the performance of IMS Connect and understand it around various aspects. Those aspects can be changed by the time range, identifiers, all those types of things. This particular report is showing me transaction counts by IMS target data store. You can see data store, the target data store, the transaction count, and the percentage of usage. If I'm using workload balancing in IMS Connect Extensions, this helps me to understand if my balancing rules are being used, right? I can also see average transaction per second numbers by target data store over here. And here's my target data store information and my transaction counts. And here's a transaction rate by data store target in a line graph. So Splunk and these off-host analytics tools allows us to break this information into various different views and view it however we want to, right? And that's what's the most important. But from a performance standpoint, this particular report might be a little more helpful. Here I've got input, OTMA elapsed time, and output elapsed time by team member. And the team member is the actual back-end IMS system that's doing the work. So this is overall performance information, right? And it allows me to quickly see spikes in OTMA elapsed time that might warrant further investigation using a tool like PA or PI. Again, that was a quick touch on those particular tools. And with that, I will wrap up and say thank you in many different languages. That's really all I have for today, and I'll turn it back over to Trevor and open it up for any questions that you might have.
Okay, thank you very much. Yes, if anyone does have any questions, if you want to type them into the chat now, I'll ask James. Or if you think of them later, then you can email me and I'll pass them on to James, and I'm sure he'll get back to you with an answer.
Absolutely.
So, yeah, I'll just pause a couple of moments to give people a chance to type. All right, so Nancy Campbell's saying, missed the beginning, did James share his contact information? Can you just give everyone your email address, please, James?
Absolutely.
Yeah, it's in the chat now.
I think I only sent it to you, though, Trevor.
Oh.
Not everyone.
Oh.
So
Okay.
I'll do it again.
Okay, let's at least read it. It's James M, so that's JAMESM at rocketsoftware.com. Oh, there we are. It's just gone to everyone. Brilliant. All right, like I say, if you do have any more questions, Blair Snyder said, always good to go back to basics, James, with how to read the performance and tuning data. IMS PA has taken away all of the individual reports I used to write or manually go through the log to get. Smiley face. So, yeah.
That's what we're here for.
Yeah, I thought you'd be pleased to hear that. Okay, I'm going to share my screen. We'll move on quickly. I notice the time's beginning to get away from us. Let's do it from here. No, I can't because I'm not presenter. Sorry, let me become presenter again. Okay, I'll be quite quick then for these bits. Yes, so news. According to IBM, 87% of all credit card transactions are processed on a mainframe. And as we know, probably most of those go through IMS. So that's why it's important for us to know that in October, the PCI Security Standards Council and the ATM Industry Association, they issued a joint bulletin to highlight a threat called an ATM cash-out attack. What this attack does, it involves criminals breaching a bank or payment card processor and manipulating fraud detection controls as well as altering customer accounts. And the result of that is that for a limited period, they can just draw as much money as they want from people's accounts and from numerous ATMs. And basically, they keep doing that until the ATMs are completely empty of any kind of cash. If you want to know any more about that, if you email me, I can send you the link to it. I'll just say that one of their recommendations is that you have some kind of file management software, or some FIM software, I mean. Anyway, let's move on quickly. There have been a few articles, and also, if you look these up, they've actually moved. So the IMS articles are now in the IMS part of the IBM Z and Linux One community, and not where they were. So we've got one by Greg Summers, Farewell to the IMS Dev Center. We've got this one, IMS Transaction Manager Advancements for 2020, which is by Sanjay Kalia, Tom Morrison, and Jack Wan, which is in IBM Systems Magazine back in November. And IBM Systems Magazine, I'm told, is stopping as well at the end of the year. And we've got this one, How to Build an IMS Database Control System by Michel Carey. And that, I think, has moved, and I haven't found where it is now. So, as always, can I ask you for feedback about this session? There's my email address on screen. If you want to make a note of that, you can let me know what you think, anything we can improve on, or anything that was good. So, our next planned meetings are in the new year. 9th of February, then, we've got Nick Griffin from BMC. He's talking about reach the IMS database 4 or 8 gig line. Now what? And then on the 13th of April, I think it'll be Thomas Esser from Rocket Software. Well, he and his team will be discussing saving CPU time with IMS database administration. And quickly, just a reminder that you can keep up to date with what's happening in the world of IMS and on the virtual IMS user group website by following us on Facebook and Twitter, or by joining the virtual IMS group on LinkedIn. URLs are all on our homepage, so there's no need to try and write them down off the screen. The hashtag to use is hashtag virtual IMS, one word. And because it's social media, everyone likes, so if you can go to our Facebook page and like us, that will be brilliant. Okay, that's all for this meeting of the virtual IMS user group. Can I thank you all for attending? Thank you to Rocket Software for sponsoring our user group. And of course, particular thanks to James Martin for today's presentation. That's it. Thank you all very much for joining the meeting. And if you celebrate it, Merry Christmas. And I look forward to seeing you in the new year on the 9th of February. So thank you all very much and goodbye.